All right, welcome everyone to week 2, video number 2 for Public Health 5101 Epidemiology. So as a reminder, in our last video, we started to talk about some of the ways that we measure outcomes that we're interested in, whether they're diseases or other health indicators. And we left off at the last video talking about counts and how there's some usefulness in discussing or assessing counts, but we really, for most health problems, need to delve deeper and understand sort of the larger denominator, the population that's giving rise to these counts of disease. So in this video, we're going to discuss prevalence and incidence. And these are the two measures of disease occurrence that are by far the most common in epidemiology. And you will learn these like the back of your hand. Because they're gonna form the basis of everything else we really measure in this class. So let's delve into it. So the first measure that we're going to discuss is prevalence, and the formal definition of this is the burden of disease at a given time. Basically what this is, it's a proportion. At this moment, what proportion of people in our population have our health indicator? So you can see the definition is right here. So our numerator is the number of people with the health indicator. Remember, again, that can mean the number of people with disease, the number of people with health outcome, however you just define it. And then our denominator is our total population size. And here's where our discussion in the last video about population becomes important. Who is in your population? Is it all U.S. Residents? Is it women? Is it children? Is it African Americans? And so that's really important, obviously, because dramatically changes your outcome depending on what your population is. So as a little reminder, population or prevalence is a proportion. So all individuals who are in the numerator must be in the denominator. So as an outcome of that, obviously, this number in the numerator is going to be smaller than this number in the denominator because the denominator incorporates the people who are in the numerator. The prevalence then will range between 0 and 1, and prevalence is commonly expressed as a percentage, so we would multiply that number by 100, so our prevalence would range from 0 to 100%. The population may be geographical units, genders, ages, races, etc. So you should always, when you're discussing your prevalence, always make mention of what population you measured. So 70% of African American women are overweight or obese. That is a prevalence measure. It's the proportion of women who are African American and who are overweight or obese. And we're going to go through some examples. And a really important point for prevalence, which will differ when we get to incidence, is that prevalence includes both new cases and existing cases. Prevalence does not care if the person got the health outcome yesterday or 30 years ago. I like to think of prevalence as a snapshot in time. If you look today, who has your health indicator of interest? What is the prevalence of smoking? What is the prevalence of HIV? What is the prevalence of breast cancer? Who essentially, to make it simple, would respond yes at this moment in time if you ask them, do you have this health outcome? Okay, so let's go through an example. And related to this video, I'm starting to post very short 1-minute videos that allow us to really work through the steps of a problem. So if you're someone who, like me, to feel comfortable with the math, wants to see every step of the problem written out in sequence, you can go to those videos, and I'll obviously be posting links. But this is just a general example that we're going to walk through together. So again, to calculate prevalence, currently, and excuse the typo there, I just see, 120,659 of the 1,553,000 residents of Philadelphia have diabetes. Okay, so we go back to our formula for prevalence. It's the number of people with the health indicator over our total population. So 120,659 is our number of people with our health indicator, our number of people with diabetes. That becomes our numerator. Our total population is our denominator. In this case, we learned that 1,553,000 is our denominator. That's our population, the residents of Philadelphia. So we're going to put that in our denominator. Then we're going to simply divide. And we end up, again, I always like to show the first zero. And in this case, I actually extended to the thousandth place because it gained us a little more information because there was a zero here. So our prevalence was 0.078, and then we multiply that by 100 and say our prevalence is 7.8%. So what this means, currently 7.8% of Philadelphia residents have diabetes. And, later on in the course, we're going to talk about, well, how do we know that, right? There are lots of different ways we could have conducted this study. We could have done a phone survey, right? And picked a representative sample of people and asked them, do you have diabetes? We could have gone to health insurance claim information. We could have gone to pharmacy refill information and who's getting insulin or who's getting metformin. Obviously, all these methods have their error involved and mischaracterization, but we'll talk about that later. But just to sort of pique your interest on how would we ever know that? So anyway, the prevalence, according to these numbers, the prevalence of diabetes in Philadelphia currently is 7.8%. Again, I don't care in this formula whether they were diagnosed yesterday or they were diagnosed 10 years ago. If we take a snapshot, a picture in time of diabetes, currently 7.8% of the population of Philadelphia has it. Okay, so let's talk a little bit more about the role of time. There's a few different ways we can characterize time in prevalence. You can think about point prevalence, that is, right now, do you currently have it? So the numerator counts the total number of cases or people with your health outcome at a given point in time. So a question that exemplifies point prevalence is, do you currently have the flu? Do you have it right now at a point in time? We can also expand our time period of interest a little to something called period prevalence. And in this case, the numerator counts the total number of cases or people with your health outcome at all points during the time period you're interested in. So have you had the flu over the past year? So again, our numerator becomes the people who have this outcome over the period we're interested in this case, who have had the flu over the past year, and our denominator is our total population. And you can imagine for something like the flu, we may care more about, or period prevalence may be more informative because the flu is really short lasting. If you did a survey, say, of Temple students, and you were able to, send an email to every single one of them and ask, do you have the flu right now? You'd end up getting a really low prevalence because the flu is short-lived. At any given point in time, if you take a picture, a very small number of people are going to have the flu, and that may not truly represent the total burden of flu on the university because you're only picking up a very small sliver of time. So it may be more informative to know this semester, have you had the flu? Again, because it's such a short-lived thing, we want to pick up more cases and know about that period. All right, so that's period prevalence. We can also think about lifetime prevalence. And again, this is for health outcomes that may come and go. And what we're really interested in is how many people in our population have experienced this health outcome. So a question that assesses lifetime prevalence may be, have you ever had the flu? And obviously you can imagine as we go from point to period to lifetime, your denominator is going to get larger because it's just encompassing more and more people who have experienced that. Okay, so for this, the key to distinguishing whether you're assessing point prevalence, period prevalence, or lifetime prevalence is really looking at the question and saying, is it wondering right now, like today, or a very short period of time? Is it trying to capture the number of cases in a period, or is it trying to capture the number of cases who have experienced this over a lifetime? Okay, as we start to become more and more experienced with prevalence, you'll see that, or you can imagine that, a number of factors affect prevalence. And we referred to this with our flu example just now. So disease duration, right? So again, if I'm assessing period or point prevalence, and I want to know today who has my health outcome, if there are health outcomes that are very short-lived, my prevalence is likely going to be pretty low, right? So you can think about, again, the flu, you can think about migraine headaches, again, these things that sort of come and go and are relatively short-lived. If you pick a given day to survey people and say, do you have this health outcome, you're only going to capture a very small number. So that's how disease duration impacts our prevalence measures. Another thing to consider is treatment effectiveness, right? So if we have an incredibly effective treatment for a disease, again, at a given point in time, you're going to have a relatively low number of people saying they have that outcome because they were able to deal with it very quickly. It's sort of like the disease duration thing. If we have very effective treatments, our duration of disease is low. The inverse is that if we don't have effective treatments for something, that as soon as someone gets a given health outcome, they're gonna have that health outcome, potentially for their entire lives. And so you actually may see a very high prevalence of diseases that don't have effective treatments because they're just accumulating within the population. You may imagine something like type 2 diabetes, which really doesn't have a treatment to the extent that, it would go away. You essentially always have it, but you're able to manage it. So if you were to measure the prevalence of type 2 diabetes, let's say among 20-year-olds versus among 60-year-olds, you're going to get a very different prevalence statistic because among the 60-year-olds, you're accumulating all of these cases of diabetes and they don't go away. They may be managed, but they really don't, for all intents and purposes, go away. So you're going to see a much higher prevalence among the 60-year-olds than the 30-year-olds because they've accumulated over time. Another factor that affects prevalence is increased incidence. And incidence, I'm kind of jumping ahead because incidence is the next thing we're going to talk about, but incidence you can essentially think of as new cases. So how many more people are getting the disease? Is the rate at which people are getting the disease speeding up? And so you can imagine that as more and more cases are coming in, your prevalence is going to get higher because you now have all these people, let's say diagnosed yesterday or diagnosed in the past week or in the past year, who are now going to respond and say, yes, I have that health outcome. Another thing is migration of cases or people with the health outcome into or out of the population. So it may not really be that more people in your population are getting sick and therefore, again, raising their hands and saying, yes, I have that health outcome. It may be but that there's population shifts and that people with a health outcome are moving into that population. So let's think of an example. So say, for example, that a certain city had a world-renowned hospital that was known to treat a certain health outcome, right? And imagine it was a health outcome for children. Imagine that people with children with that health outcome moved to that city so their child could receive regular care. If we took a survey and measured the prevalence of that health outcome over time, it would probably look like it's increasing because people are moving their children with that disease to be near the hospital. And so it's not really that the people who were always in our population are getting sicker, but that there's just these new cases of disease moving in. And that may seem like an extreme example. How often does it happen that people move near a hospital? But you can imagine, right? We have population and demographic shifts all the time. And with refugee groups or immigrant groups or people who move to certain places for a certain reason, their health profiles are going to be different. So we're going to see shifts in the prevalence of diseases just because who's in our population and where they might have come from and the circumstances that they came to a place with. In the same way, we may see migration of disease-free people or non-cases into or out of our population. So there may be some reason why healthier people are moving into a certain place or healthier people are moving out of a certain place. And so in that case, right, the denominator, oh wait, let me think about this. So our denominator, that's it. The healthy people are moving out of our denominator, and our denominator is decreasing, while our numerator, our people with our health outcome, is staying the same. And then finally, changes in detection, right? So if, I think at a cursory thought, we think that the definitions or diagnostic criteria for disease are fairly stable, and they're actually not. My favorite and the most salient example of this is autism, right? That, in the past 20 years, we've had an incredible increase in our understanding and awareness of autism. Our definitions have changed. Our doctors are more, and clinicians are more on the lookout for it. Parents are more aware. So we're seeing this rise in autism diagnoses that actually a great proportion of it is not necessarily that these are like newly sick kids, but that our criteria for diagnoses and our awareness are increasing. So you're going to see increases in prevalence of autism because more kids are being diagnosed, not because essentially the true health state of the population is changing. So I think it's really important for students to be aware of these factors because, on a daily basis, we read about, what's happening with the prevalence of autism and the number of kids with autism, or, the number of people with any one number of health diseases or health outcomes. And a really informed consumer of that information will say, is it really that my population is actually getting sicker? Is there actually increased incidence, or is something else going on with this health outcome? Did we, have a population shift as to who's living here? Did we have changes in the diagnostic criteria? Has, the treatment become more effective or less effective over time, right? So we're not able to sort of get cases of disease out of our numerators quickly. These all are really important factors in interpreting the numbers of the burden of health on a population, otherwise known as the prevalence of the health outcome in your population. Okay, so that was all about prevalence, a really important statistic. I encourage you to do the lab assignment problems, look through our short video on how to do prevalence, and really feel confident about what prevalence is, when we are measuring it, and how to calculate it.